Hello my scholars, you are welcome to my school YouTube channel and my name is Frank. In today's video, we shall be tackling JAMB CBT physics past question for the year 2006. So relax, do not go anywhere and we'll be right back. You are welcome back to my school YouTube channel. In today's video, we shall be answering question 26 to 50. So let's begin with question 26. The process through which free electrons leave the surface of hot metals is known as A. Photon emission, B. We have photo emission, C. We have thermonic emission, while D. We have electron emission. So the answer to this question is option C, thermonic emission. So thermonic emission is the emission of electron from the surface of metal when heat energy is imparted to it. Okay, so for option A, photon emission, okay, has to do with the release of electrons as a photon when electrons transition between energy level in an atom. While for option D, electron emission. So electron emission is just a general term used to describe any process which involves the release of electron from a material. Okay, so but the answer to this question is option C, thermonic emission, which is the process through which free electrons leave the surface of hot metals. Question 27. The battery connection that permits current to flow across a PN junction is called A. We have a reverse biased, B. We have forward bias, C. Amplification, and D. Rectification. So the answer to this question is option B, forward bias. Okay, so the battery connection that permits current to flow across a PN junction is called forward bias. So in this connection, the positive terminal of the battery is connected to the P-type semiconductor, while the negative terminal is connected to the N-type semiconductor. This reduces the potential barrier across the PN junction, allowing current to flow across it. Okay, so that makes option B the correct answer to this question, while option A is just the opposite of option B. Okay, so in option A, no current flows because the connection is actually the reverse of the forward bias, while for option C, amplification is just the process of increasing the amplitude of a signal, while for option D, rectification has to do with converting AC to DC voltage. Okay, but the answer to this question is forward bias, which is the battery connection that permits current to flow across a PN junction. Question 28. One of the properties of gamma rays is that they are A. neutral, B. massive, C. positively charged, and D. negatively charged. So the answer to this question is option A, neutral. Okay, so gamma rays are electromagnetic radiation and they do not carry any charge. Okay, they are also referred to as massless photons. Okay, so that makes option A the correct answer to this question. So remember that they are massless photons, so they are not massive, they are not positively charged, rather they are neutral. Okay, and D, they are not negatively charged, they are neutral, they do not carry any charge. Okay, so that makes option A the correct answer to this question. Question 29. A radioactive element has a half-life of 4 days. The fraction that has decayed in 16 days is, so let's move over to the board to provide answer to this question. So the radioactive element has a half-life of 4 days, then total time is 16 days, right? So to provide answer to this question, we simply make use of this formula. N is equals to N naught, then in bracket 1/2 raised to power N. Okay, so N here, okay, represents the remaining fraction. That is after the radioactive element has undergone decay. Okay, while N naught here is the original mass of the radioactive substance. Okay, why N here stand, this small letter N here stand for the number of half-life. So in order to do this, let's first of all calculate for the number of half-life. So the number of half-life N, small letter N, is equals to total time all over half-life. okay, all over half-life. So this will be 16 divided by 4, and that will be equals to 4. Okay, now remember that our N naught here, which is the original mass of the radioactive substance, is 1. Okay, it's assumed to be whole. Okay, so we can now calculate for the remaining fraction. So to calculate for the remaining fraction, N will now be equals to 1 over 2 raised to power N. But remember that our N here is equals to 4. So here we'll be having 1 over 2 raised to power 4. So the 4 here affects everything inside the bracket. So this 1 over 2 raised to power 4 means 1 raised to power 4 and also 2 raised to power 4. Okay, so 1 raised to power 4 is 1 and 2 raised to power 4 is 16. Now we can now calculate for the decayed fraction. Okay, so the decayed fraction will be equals to the original mass of the radioactive substance, which is N naught, then minus the remaining fraction, okay, which is N. So in this case, we're having 1 minus 1 over 16. Okay, so this one is also over 1. It doesn't change anything. So LCM of 1 and 16 is 16. So we write 16 here. Then 1 into 16 is 16. So 16 times 1 will give us 16 here. Then our minus sign. Then 16 into 16 is 1. Then 1 times 1, which is this one, is 1. So the denominator will be having 15 over the numerator, sorry, will be having 15, while the denominator will be having 16. So this is the fraction, okay, that has decayed of the radioactive material. So let's return back to the screen to pick the correct answer to this question, and that is option A, 15 over 16. Question 30. The theory of electronic conduction in solids, which satisfactorily explains the properties of conductors, insulators, and semiconductor is: A, we have the string theory, B, particle theory, C, group theory, and D, band theory. So the answer to this question is option D, band theory. Okay, so the band theory explains that the energy level of electron in a solid is in band, right? So this theory describes how this band affects the electrical property of materials. Okay, for example, in conductors, the overlapping bands allow free movement of electrons, while in semiconductor, because of the large band gap, okay, there is no free movement of electron. Okay, hence insulators do not conduct electricity, while in semiconductor, though they have smaller band gap when compared to insulators, so they only conduct electricity under certain conditions, such as doping, temperature. Okay, so the answer to this question is option D, band theory. Question 31. Which of the statements above are correct about nuclear fission? I think the first thing first is for us to define what nuclear fission is. Okay, so nuclear fission is just a process whereby a heavy nuclei split into two or more nuclei with the release of energy. Okay, so this process is actually brought about by the injection of electrons. So when the nucleus of that heavy nuclei is injected with a neutron, then it will bring about the splitting. Okay, so let's go through the options that are given to us. So 1, the number of neutrons released exceeds the number that caused the fission. I think that is very true. Okay, I is very true, because first of all, remember I said it is neutrons, okay, that actually brings about nuclear fission, right? So during the process, more neutrons are released. Now remember, you've heard of chain reaction. So the chain reaction is as a result of those released neutrons that causes or that induces further nuclear fission. Okay, so I is correct. Then II, there is loss of mass. Okay, so II2 is also correct, because the energy that are released, okay, as a result of small amount of mass of the substance being converted into energy, as described by Albert Einstein law, okay, or described by Albert Einstein's equation. Okay, why energy is produced. Yes, during nuclear fission, energy is produced. Why IV, smaller nuclei merge to form larger nuclei. I think IV is describing about nuclear fusion. Okay, so I is correct, II is correct, then III is correct. So let's move through the options and see. Okay, I think the correct option to this question is option C, II, and III only. Why IV is not correct? Why? Because IV is talking about nuclear fusion and not nuclear fission. Okay, so that makes option C the correct answer to this question. Question 32. A certain manufacturer wishes to make an N-type semiconductor. Which materials would he select for doping? Okay, so for the manufacturer who wish to make an N-type semiconductor, so the type of material he should select should be a material that has more electron on its atomos share than the semiconductor itself. Okay, so remember that semiconductors have 4 electrons on the atomos share. So if you want to produce an N-type semiconductor, then you need a material that has more than 4 electrons on its atomos share. So in this case, we are going to be using tetravalent element. That is, elements that have 5 electrons on their atomos share. Okay, so let's go through the options and see the tetravalent element. So for option A, we have boron and antimony. Boron is a trivalent, meaning it has less electron, okay, than the semiconductor material, but antimony is a pentavalent electron, meaning it has 5, okay, but here they needed 2. Okay, so option A is not correct. Why option B, boron is trivalent, while sodium is monovalent. Okay, so option B is not also correct. Why option C, we have aluminium and indium. So I think both of them are all trivalent elements. While for option C, we have arsenic and antimony. So arsenic and antimony are pentavalent electron, meaning that they are pentavalent elements, meaning that they have 5 valent electrons, okay, on their atomos share. So the material that the manufacturer should choose is option D, arsenic and antimony. And the reason is because they have more electrons on their atomos share than the semiconductor. So when these materials are doped, okay, when these materials are used to dope a semiconductor material, okay, you are going to be having 1 electron left, or you are going to be having more electron. And this 1 extra electron will serve as the charge carrier in that semiconductor material, which will result in the N-type semiconductor. So that makes option D the correct answer to this question. Question 33. A PN junction diode is used as A rectifier in a DC circuit, B an amplifier in DC circuit, C an amplifier in an AC circuit, D a rectifier in an AC circuit. So the answer to this question is option D, a rectifier in an AC circuit. So a PN junction diode is commonly used, okay, as a rectifier in a power supply to rectify AC voltages. Now remember that PN diode or junction diode are transistors, and transistors permit current to flow in only one direction. Okay, so for that reason they are used as rectifier in an AC circuit to rectify AC voltages. So that makes option D the correct answer to this question. Question 34. An object placed 10 cm from a concave mirror of focal length 5 cm would have its image A at the center of curvature, B at the radius of curvature, C at infinity, D 10 cm from the focus. So the answer to this question is option A, at the center of curvature. Okay, and the reason for that is because for a concave mirror, okay, the center of curvature is twice the focal length. Okay, so if the focal length is equal to 5 cm, that means the center of curvature is equal to 10 cm. Okay, so and remember that we are told that the object is placed 10 cm from a concave mirror, right? So that means the object is actually placed at the center of curvature. Okay, so when the object is placed as the center of curvature, okay, the image will also be formed at that same point. So that makes option A the correct answer to this question, meaning the image will be formed at the center of curvature. Why? Because the center of curvature is equal to 10 centimeter and the object is placed at 10 centimeter. So the image will be formed at that same point, which is at the center of curvature. So that makes option A the correct answer to this question. Do you know you can take practice question with our JAMB simulated CBT past question? All you need to do is to click on the link in the description below, and that will take you to Myschool website. There you will have to download Myschool mobile app for your Android devices and Myschool software for your laptops and computers. Please go ahead and start practicing. Moving on to question 35. A submarine is observed to rise from a real depth of 80 meters to 60 meters in water. Calculate the change in apparent depth. Refractive index of water is equals to 4/3. So let's move over to the board to provide answer to this question. So remember that refractive index is equals to real depth, okay, let's use capital letter R, all over apparent depth, okay? So let's use AD for apparent depth, right? So if you check this question very well, we are given two depths because they said the submarine rises from 80 meters, okay, to 60 meters according to the question. So first of all, we'll calculate for the apparent depth, okay, at the real depth of 80 meters. So we know n to be equals to this. So we can just make the apparent depth the subject of formula. Basically, that is what we are calculating for. So here we'll be having the apparent depth, okay, that is when real depth is equals to 80 meters. So apparent depth will be equals to real depth, okay, let's add it to it, all over the refractive index, okay. So apparent depth at this real depth will be equals to 80 all over 4/3, okay. So 80 all over 4/3 is still the same as 80 times 3 divided by 4, okay, because 80 over 4/3 means 80 divided by 4/3, okay. So we can change this, we keep this, we change this, and we flip this, okay. So this becomes 80 times 3 all over 4. So that is how I arrive at 80 times 3 all over 4. So 4 here is 1, 4 here is 20, okay. So 20 times 3, that will be equals to 60, okay. So at the real height, at the real depth of 80 meters, apparent depth is equals to 60 meters, okay. So let's move on and calculate for when real depth is equals to 60 meters. So we are using the same formula. Remember, refractive index is equals to real depth all over apparent depth. So we are looking for apparent depth here, so we'll make it the subject of formula, so that apparent depth is equals to real depth then divided by refractive index, which is 4/3, okay, which is divided by refractive index. So here we'll be having 60 all over 4/3, so that apparent depth will now be equals to 60 times 3 all over 4, okay. So 2 here is going to give us 2, and 2 here is going to give us 30, then 2 here will give us 1, then 2 here will give us 15. So 15 times 3, that will be equals to 45 meters. So in this case, we can calculate for the change in apparent depth, okay. So the change in apparent depth will be equals to the apparent depth at the real height of 80 meters, then minus the apparent depth at the real height of 60 meters. Okay, so here we'll be having 60 meters minus 45 meters, and this will be equals to 15 meters. Okay, so the change in apparent depth is equals to 15 meters. So let's move over to the screen to pick the correct answer to this question, and that is option C, 15 meters. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, put on the notification bell to get informed as soon as we release the next videos. Question 36. Non-luminous objects can be seen because they A. reflect light, B, are near, C, are polished, and D, emits light. Okay, so first of all, what are non-luminous objects? So non-luminous objects are those objects that do not produce light by themselves. Okay, they are the opposite of luminous objects, meaning objects that emit light. For example, the sun is an example of luminous object. So the sun produces light by itself. It doesn't depend on anything to cause it to produce light. Right? So non-luminous objects, since they do not produce light, okay, but they have the ability to reflect light, okay, and it is because of this, the ability to reflect light, that allows us to see them. Okay, so the answer to this question is option A, reflect light. So non-luminous objects can be seen because they reflect light, not because they emit light, but because they reflect light. And it's this because of this reflection that makes them visible to us, that helps us to see them. Okay, so the correct answer to this question is option A, reflect light. Question 37. The wavelength of the first overtone of a note in a closed pipe of length 33 centimeters is, so let's move over to the board to provide answer to this question. So remember that fundamental frequency occurs in a closed pipe, okay, when the length of the closed pipe is equals to lambda all over 4. Okay, so in this case, the first overtone will occur, okay, when L is equals to 3 lambda all over 4. Okay, remember that for closed pipe, they have odd overtones, right? So in this question, we are calculating for wavelength. So we can make wavelength the subject of formula by simply cross multiplying. So if we cross multiply, we're having 4L is equals to 3 lambda. So we divide both sides by 3, so that lambda is equals to 4L divided by 3. Okay, so here we just substitute for the value of the length. So we're having 4 times 33. Remember, the length is given to us to be equals to 33 centimeters, then divided by 3. So 3 here is 1, and 3 here will be 11. So 4 times 11, that will be 44 centimeters. Okay, so at the first overtone, the wavelength of the note in a closed pipe will be equals to 44 centimeters. So let's move over to the screen to pick the correct answer to this question, and that is option B, 44 centimeters. Question 38. A person can focus objects when they lie beyond 75 centimeters from his eyes. The focal length of the lens required to reduce its least distance of distance vision to 25 centimeters is. So let's move over to the board to provide answer to this question. So basically, this is a question on length, and here, but in length question, you can as well use mirror formula. So we are going to be using mirror formula. Okay, so our V is equals to minus 75 centimeters, and the reason is because the image of the object is formed in the same place as the object. Okay, so using the mirror formula, we can calculate for the focal length. So here, 1 over F is equals to 1 over V plus 1 over U. Okay, so 1 over F will be equals to 1 over minus 75 plus 1 over 25. Okay, so here the LCM is equals to 75, right? So that minus 75 into 75 will be equals to minus 1. So minus 1 times 1 will give us minus 1 here. Then our plus. Then 25 into 75 is going to give us 3. Then 3 times 1 will be equals to 3. Okay? So at the numerator, we'll be having 2. While the denominator still remains 75. So here, 1 over F is equals to 2 over 75, right? So if we cross multiply, since we are looking for F, not 1 over F, so if we cross multiply, we're having 2F to be equals to 75. So we divide both sides by 2, so that F is equals to 75 divided by 2, and this will be equals to 37.5 centimeters. Okay, so the length of the focal length required is equals to 37.5 centimeters. So let's return back to the screen to pick the correct answer to this question, and that is option A, 37.50 centimeters. Question 39. A conductor has a diameter of 1.00 millimeters and a length 2.00 meters. If the resistance of the material is 0.1 ohms, its resistivity is, so let's move over to the board to provide answer to this question. So remember that resistance is equals to resistivity times length all over area. Okay, but in this question we are asked to calculate for resistivity, so we just make it the subject of formula, so that if we cross multiply, we'll be having resistivity times length to be equals to the resistance then times area. Okay, so if we divide through by the length, you'll be having resistivity to be equals to area to be equals to resistance times area all over length. Okay, but our diameter is given to us because of the area. We have to calculate for area. Remember that area is equals to pi r square. Okay, now the wire is assumed to be in circle, okay, to be circular in shape. Okay, so our diameter is given to us to millimeter, yes, so we have to convert it to meter. Okay, but remember that radius is equals to diameter divided by 2. So if we divide this by 2, if we divide 1 by 2, we'll be having 0.5 mm. But this 0.5 mm, we'll have to convert it to meter by simply dividing by 1000. Okay, so if we divide by 1000, we'll be having 0.0005 meters. Okay, right? Now, the next thing we can now calculate for area. So area here will be equals to 22 all over 7, then times, so let's put this in standard form. If we put this in standard form, we'll be having 5 times 10 raised to power minus 4. Okay, so we're having 5 times 10 raised to power minus 4. So if we, of course, this is squared. Okay, take note of that. This is squared because the radius here is squared. So here we'll be having 27 all over 7 times 25, then times 10 raised to power minus 8. Okay, so we can decide to reduce this, so that we reduce this here to so that we can reduce here to minus 7, right? So the decimal point is actually here. So if we move it one place inside, we'll now subtract 1 from it. We'll now add 1 from here, because we actually move our decimal point from our right to our left. So in that case, here will be positive. So here we're having plus 1. So minus 8 plus 1, okay, will be equals to minus 7. So that we'll be having 22 all over 7 times 2.5, okay, times 10 raised to power minus 7. So if we multiply add this, we'll be having 7.857 times 10 raised to power minus 7 meters square. Okay, so this is the value of the area. Then we can now substitute. So if we substitute into our formula so that we can calculate for the resistivity, we'll be having 0.1 for the value of the resistance, then times the area, which is 7.857 times 10 raised to power minus 7, then divided by 2. Okay, so now here we're having 0.1. Of course, the essence of all this is so that we can easily divide. So since this place is 0.1, okay, so we move this, we write this in standard form. So if we write this in standard form, we'll be having 1.0 times 10 raised to power minus 1. So 1 times 7.857 still remains 7.857. But here we increase to minus 8, okay, because we apply the law of indices, the multiplication law of indices, when we have multiplication sign here, so that we still have 7.857 times 10 raised to power minus 8 all over 2. So we cannot divide gradually. Okay, so 2 into 7 will be 3 remainder 1. So we put our point. Then the one that is left, we put it here. So 2 into 18, that will be equals to 19. Then 2 into 5, that will be equals to 2. Okay, that will be equals to 2. remainder 1. So 2 into 17, that will be equals to 6. Okay, remainder 1. So 2 into 10, that will be 5. We're having times 10 raised to power minus 8. Okay, so we can reduce this to be 3.927 times 10 raised to power minus 8 ohms meter. Okay, so the value of the resistivity is 3.927 times 10 raised to power minus 8 ohms meter. So let's move over to the screens to pick the correct answer to this question, and that will be option D, 3.93 times 10 raised to power minus 8 ohms meter. Okay, remember here that this place was rounded to 2 decimal places. Okay, so if we round our own to 2 decimal places, we'll be having exactly this, which is 3.93 times 10 raised to power minus 8 ohms meter. Okay, so option D is the correct answer to this question. Question 40. The diagram above represents the stress strain graph for a typical metal rod. What does the S represent? Okay, so this is a graph of stress against strain. Okay, so this graph simply shows what happens to a material when force is applied to it. Okay, so from this point to this very point here is called, okay, to this very end here is called proportionality limit. Okay, why this point here is called the elastic limit. Okay, why this second point is called the yield point, why this point is called the breaking point. Okay, so at the breaking point, the material can no longer withstand any applied force. So any force that is applied to the material will cause the material to break. Okay, so this point here marked S is the breaking point, and that makes option A the correct answer to this question. Question 41. In the diagram above, the pressure of the gas is, okay, so from this diagram we can see that the pressure of the gas is due to atmospheric pressure, the reason for this area, and the height of the mercury in the U-tube. Okay, so we know that atmospheric pressure is equals to 76 centimeter and the height of mercury is equals to 10 centimeter. So we just add them together to get the pressure of the gas. So in this case, we'll be having 76 centimeters plus 10 centimeters, and that will be equals to 86 centimeters. Okay, of course, we are talking about pressure of the gas. So in that case, it's going to be 86 centimeters of mercury. Okay, so that makes option A the correct answer to this question. Question 42. A mirror of weight 75 Newton is hung by a cord from a hook on the wall. If the cord makes an angle of 30 degrees width horizontal, the tension in the cord is, so let's move over to the board to provide answer to this question. So to solve this question, it's necessary for us to make a sketch. Okay, so let's make a sketch of the mirror. Let's say this is the mirror, and it makes an angle of 30 degrees. So here is 30 degrees, here will also be 30 degrees. But remember, the cord has two components, okay, the vertical and the horizontal component. So we can take this up, so here we'll be having 60 degrees, and here will also be 60 degrees. So the tension in the cord can be resolved, okay, into the horizontal and vertical component. So if we are to use 30 degrees, then the tension, okay, in the vertical component will be equals to T sine 30 degrees. So in this case, we are going to be having 2, okay? But if we are to use 60, then the horizontal component, the vertical component will be Ty will be equals to T cos 60, okay? So depending on any one that we are using, your answer will be correct, because remember that cos 60 and sin 60 are the same, right? Since we have two chords here, so let's say let the total chord, let the tension in the both chords be equals to T. So that means you'll be having Ty plus Ty will be equals to T. Okay, so if we are using this, then we are using T to represent the total, right? Now for this mirror to be in equilibrium, remember the vertical force that is acting upward must be equal to the vertical force that is acting downward, which is the weight of the mirror. Okay, remember the weight of the mirror is acting downward and is given to us to be equal to 75 Newton. Okay, since we are saying the total tension be Ty plus Ty, which is the tension here, and this other one equals to T, while here we'll be having T sine 30 degrees to be equals to 75 degrees. Okay, the reason for this is because for the mirror is in equilibrium. Okay, so the force that is acting upward will balance out the force that is acting downward. Okay, so since we are looking for T, we just divide both sides by sine 30. Now remember that sine 30 is equals to 0.5 or 1 over 5. So here we'll be having T to be, okay, T times 1 over 5. Let's use 1 over 5 instead of 0.5. Of course, 1 divided by 2 is 0.5. Okay, so here will be equals to 75. So since we are looking for T, we just divide both sides by, or we just multiply both sides by 2 over 1. So T times 1 over 2 times 2 over 1 will be equals to 75 times 2 over 1. So that this will cancel out each other. 1 over 2 will cancel out 2 over 1. Okay, so that T is equals to 150 Newton. Okay, so the tension in the cord is equals to 150 Newton. So let's return back to the screen to pick the correct answer to this question, and that is option D, 150 Newton. Question 43. In a gas experiment, if the volume of the gas is plotted against the reciprocal of the pressure, the unit of the slope of the resulting curve is, so let's move over to the box to provide answer to this question. So we have a graph and the vertical component of the volume, and the volume is plotted against the reciprocal of pressure, which is 1 over pressure. Okay, so in this case we are actually looking for the slope of the graph, right? So remember that slope is change, okay, change in, so slope is change in volume all over change in the reciprocal of pressure, which is the same thing as V all over 1 over P, right? So this becomes V times P, okay? But remember that P is equals to, V is equals to, the unit of V is meter cube, okay? And the unit of pressure, okay, is Newton meter per second, okay? Because pressure is equals to force all over area, right? So force is Newton and area is meter squared. So you'll be having this. Okay, since here is m raised to power 3 and here is m raised to power minus 2. So if we apply the law of indices here, definitely we are going to be having Newton meter at the end of the day. But remember that Newton meter is the same thing as joule, and joule is the unit of work. Okay, so the unit of the slope of the resulting curve is joules. So let's move over to the screen to pick the correct answer to this question, and that is option D, okay, because the unit of work is joule. Okay, so that makes option D the correct answer to this question. Question 44. A shooter wants to fire a bullet in such a way that its horizontal range is equal to 3 times its maximum height. At what angle should he fire the bullet to achieve this? So let's move over to the board to provide answer to this question. So here we are told that the range is equals to 3 times the maximum height. So but remember, range is calculated using u square then sine 2 theta all over g. Okay, and this will be equals to 3 of maximum height. So here we'll be having 3 times maximum height, which is u square sine square theta all over 2g. Okay, so we can remove the terms that are common on both sides, which is g. So let's remove g and g. Then we can also remove the u squares and remove u squares. So here we'll be having sine 2 theta to be equals to 3 sine square theta all over 2. Okay, but remember that in identity, okay, sine 2 theta is equals to 2 cos theta sine theta. Okay, so the whole thing here is equals to 2 cos theta sine theta, and this will be equals to 3 sine square theta all over 2. Of course, this is also over 1, so we can now cross multiply. So if we cross multiply, we're having 4 cos theta sine theta is equals to 3 sine square theta. Okay, so sine theta here can remove 1 sine theta from here, so that we'll be having, okay, so let's remove it. So here we'll be having 4 cos theta to be equals to 3 sine theta. Okay, now remember that tan theta is equals to sine theta all over cos theta. So let's achieve that. So in order to achieve that, we'll have to divide both sides by cos theta. So if we divide both sides by cos theta, we'll be having 4 is equals to 3 sine theta divided by cos theta, right? So let's bring this to this side. Of course, we have to remove this 3 from here. So in order to remove this 3 from here, then we must multiply both sides by 1 over 3. Okay, so that if we multiply here by 1 over 3, 4 times 1 over 3, then on this I'll be having 3 sine theta all over cos theta, then times 1 over 3. So this 3, we take out this 3. So that at the end of the day, let's write this part out. But remember that sin theta all over cos theta is equals to tan theta. So here, let's put tan theta to be equals to 4 all over 3. Okay, so tan theta will be equals to 1.333. Okay, because 4 divided by 3, you are going to be having this. Then we are not looking for tan theta, but we are looking for theta. So we have to take the tan inverse of both sides, so that theta is equals to tan inverse of 1.333 in brackets. And this will be equals to, of course, this will be equals to approximately 53 degrees. Okay, so the angle that the shooter have to shoot, okay, have to fire the bullet to achieve this is 53 degrees. Okay, so that makes option B the correct answer to this question. Do you have any question to ask? If yes, click the link in the description below, and that will take you to my school website. There you can ask all your questions, and our team of solution providers will provide answers to all your questions within a short period of time. Moving on to question 45. An engine of a car of power 80 kilowatts moves on a rough road with a velocity of 32 meters per second. The forces required to bring it to rest is, so let's move over to the board to provide answer to this question. Now remember that power is equals to work done, okay, all over time. And remember, work done is force times distance all over time. Okay, so we can rewrite this to be equals to force times x all over t. Okay, if you multiply this, we still return us back to this. But remember that x over t is equals to v. Remember, s stands for distance and this is time, which gives us velocity. So that our power also could be equals to force times velocity, because in this question we are not given distance and we are not given time, so we're only given velocity. Okay, so now we are asked to calculate force, and we know our power to be equals to 80 kilowatts, right? So we can convert this to just watts by having 80 times 10 raised to power 3 watts. Okay, so if we put it here, we'll be having 80 times 10 raised to power 3 is equals to force, okay, times velocity, which is 32. So we divide both sides by 32 since we are looking for F. So that F is equals to 80 times 10 raised to power 3 all over 32. So we can divide, okay, 8 here will give us 4, 8 here will give us 10, then 4 here is 1, 4 here is 2.5, okay, so this gives us 2.5 times 10 raised to power 3 Newton. Okay, so this is already in standard form, so there's no need. So the force required to bring the car, okay, to rest is equals to 2.5 times 10 raised to power 3 Newton. So let's return back to the screen to pick the correct answer to this question, and that is option D, 2.50 times 10 raised to power 3 Newton. Do you have better solution or steps to any of these questions? If yes, go to the comment section below to comment the question number and the solution you wish to share. Question 46. A progressive wave equation is represented by y is equals to a sine in bracket 150 pi t minus pi s all over 4. If the phase difference of a progressive wave is 45 degrees, the value of s in the equation is. So let's move over to the board to provide answer to this question. So to provide answer to this question, we have to compare this with the original progressive wave, okay? Original progressive wave equation. So original progressive wave equation is written as y is equals to a sine in bracket wt minus phi, okay? So where phi here stands for the phase difference, or it's called this phase difference. So we can just compare. So remember, this is our t, we have t here, then our omega here actually represents 150 pi. Okay, so here our phi represents pi x all over 4. Okay, so our phi, which is the phase difference, is equals to pi x all over 4. But remember, in this question we're told that the phase difference is equals to 45 degrees. Okay, so in this case we have to convert this 45 degrees to radians. Okay, so if we do that, we'll be having that this 45 degrees is equivalent to pi all over 4. Okay, because in radian 180 degrees is equals to pi. So if we divide 180 degrees by 4, that will give us 45 degrees. Okay, so here, since the phase difference is equals to pi all over 4, now our pi s all over 4 will be equals to pi all over 4. Okay, so we can cross multiply. So if we cross multiply, we're having 4 pi x is equals to 4 pi. Okay, so since we are looking for x, we just divide both sides by the coefficient of s, which is 4 pi. So that s is equals to 4 pi divided by 4 pi. Okay, and 4 pi divided by 4 pi, that equals to 1 centimeter. Okay, so the value of s in the equation is equals to 1 centimeter. So let's return back to the screen to pick the correct answer to this question, and that is option C, 1 centimeter. Question 47. The frequency of the wave in the diagram above is, now remember that frequency is the reciprocal of period, right? And period is simply total time all over number of circles described. So if we look at this graph very well, we know that from here to here is a semicircle, while from here to here is another semicircle. So if we put this together, that will be equals to 1 circle. And to describe this, 1 circle actually took 4 seconds, okay, to do that. Meaning that from here we can actually get the value of period, right? So in this case, period will be total time divided by the number of circles, which is 4 all over 1. So in that case, period is equals to 4, okay, 4 seconds. But remember that frequency of a wave is equals to the inverse of the period, right? So in this case, we'll be having frequency to be equals to 1 all over t. But remember that our t is equals to 4, which is total time taken all over number of circles. So from this graph, it's only 1 circle that is described, okay? And it actually took about 4 seconds to get that 1 circle. So our t is equals to 4 seconds. So to get the frequency, we just substitute 4 here. So that we'll be having 1 all over 4. And 1 all over 4 is equals to 0.25. Okay? So in this case, the frequency is equals to 0.25 Hz. So that makes option B the correct answer to this question. Question 48. Use the diagram above to answer the question below. Which of the following diagrams represent the magnetic field of 2 isolated unlike poles? Okay, remember that for 2 isolated unlike poles, they attract each other, right? While for similar poles or like poles, they repel each other. So let's look at option A. So if you look at option A, we have the north pole and we have the south pole. So they are trying to tell us here that they repel each other, okay, but the poles are alike, so this cannot be the answer to these questions, right? The poles here are unlike, but from the diagram you can see that they are trying to show us that they are repelling each other, which is not true. They are supposed to attract each other, okay? So if you look at option B, right, remember that magnetic flux line actually emerges or starts from the North Pole. But if you look at this diagram, you can see that it's actually flowing from south to north, okay, which is not also true. Then if you look at this, I think they are trying to show that repulsion between like charges. But here we have North Pole and we have South Pole, so this is not also correct. And even the direction of the magnetic flux line is not also correct, okay? Then let's look at option D. So here we have North Pole and here we have South Pole. And if you look at the direction of flow, it's actually from the north to the south, okay? So the correct diagram that represents the magnetic field of two isolated unlike poles is option D, okay? And that makes question D the correct answer to this question. Question 49. Use the figures above to answer the question below. Which of the following diagrams represents correctly an NPN transistor? Okay, remember we also have PNP transistor. So this is just how to identify it. First of all, identify the base, identify the emitter, and identify the collector. Okay, so for a PNP transistor, of course, I'm not answering this question. I'm just trying to explain how you can identify between them if you are given a diagram, okay? So for a PNP transistor, you will see an arrow that is moving from the emitter towards the base, okay? So if you look at option A is a good example or is the diagram of a PNP transistor because the arrow is actually moving from the emitter towards the base, okay? While for the NPN transistor, that arrow is moving from the base, okay, towards the emitter. So let's look for that. So if we look for that, that makes option B the correct answer, because if you look at this very well, you'll see that the arrow is moving from the base towards the emitter. Okay, so this diagram represents the NPN transistor and diagram A represents the PNP transistor. Okay, but for the sake of this question, because we are asked which diagram represents correctly an NPN transistor. Okay, so for the sake of the question, the correct answer is option B. How do you identify it? The arrow is moving from the base towards the emitter. Okay, so that makes option B the correct answer to this question. Question 50. When the base current of a common emitter transistor is kept at 0, it operates in the A, active on region, B, breakdown region, C, saturation region, and D, cut off region. Okay, so the answer to this question is option D. So when the base current of a common emitter transistor is kept at 0, the transistor operates in the cut-off region. Okay, so in this state, the transistor is essentially turned off. Okay, meaning that there is no flow of current from the collector to the emitter. Hence, it behaves like an open switch. Okay, so that makes option D the correct answer to this question. So for this region, active on region, this is when the transistor behaves like an amplifier. So here it amplifies signals. Okay, while for the breakdown region, in this region or in this state, any increase in voltage will damage the transistor. Okay, while for option C, saturation region, at this region, the transistor is fully on, okay, allowing maximum collector current. Okay, but the answer to this question is option D, the cutoff region, where the transistor behaves like an open switch. Okay, so option D is the correct answer to this question. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next video.